Hello everyone, welcome to DevOps and Data Simplified. This video is the second one in the end-to-end SSL or end-to-end encryption playlist that we have. And in today's video, I'll be guiding you through setting up the end-to-end encryption in your Kubernetes cluster with the help of Cert Manager and LetsEncrypt. So let's get started. If you haven't already, please make sure that you go through the first video in this series where I explain the end-to-end SSL concepts. Now, let's get started with some assumptions first. Before we begin, here are few prerequisites. Since we will be doing it with a managed Kubernetes cluster, please make sure that you have access to any of the cloud provider such as AWS, GCP or Azure. You need to have some basic understanding of Kubernetes, its services, and the concept of an ingress controller. Now let's talk about the certificate provisioning. In this video, we will provision the certificate with the help of Cert Manager and LetsEncrypt. Cert Manager is a powerful Kubernetes add-on which helps manage the certificates, whether you need any self-signed certificates or the ones from trusted issuer like LetsEncrypt. Cert Manager makes this process very easy. Some of the few things Cert Manager can handle: requesting a certificate, renewing the certificate before it expires, deploying the certificate to the right workload. And we'll be using Cert Manager to request the certificates from LetsEncrypt. LetsEncrypt is a free, automated and open certificate authority that can provision the SSL or TLS certificates. These certificates are widely trusted and ensure secure communication between the user and your application. In our setup, we'll be using LetsEncrypt's ACME or ACME protocol to automatically provision the certificates for our domain. Now, let's begin with the hands-on. So in today's session, we'll be using Microsoft Azure as our cloud provider, and let me take you through the resources that we have already spinned up. So we have spinned up one Kubernetes cluster. This is our Kubernetes cluster. We have named it as E2E SSL-AKS. As you can see, we have already one system node pool, and another is the workload pool to spin up our workloads. We have also spinned up our application gateway. So this is an application gateway that we have in the Azure, and other than these two resources, we have also spinned up the DNS zone. So this is the DNS zone, which is already registered with one of the DNS service providers, and this should be publicly accessible whenever we add our record inside it, right? So as of now, as you can see, there are no record sets over here. So let's begin. Okay, so we'll be starting with the installation of the Cert Manager first. Cert Manager we can install in the form of a Helm chart. So as you can see, this is the command that I'm going to execute: Helm install Cert Manager. The repo name, the namespace will be Cert Manager. Then this is the specific version that I'm choosing. CRDs, I'm enabling it by default, and since we are going to use it with Azure and we need to have Cert Manager the access of the workload identity, we'll enable it from the values. So I have made a little bit of changes in the Cert Manager values. If I go back to the values.yaml, these are the additional values that I have added. Pod label, Azure workload identity use, true, and service account label, Azure workload identity use, true. So we'll go back and we will execute the Helm install command. Let's go back and log into the Kubernetes cluster. Yes, so this is the Kubernetes cluster that we have. As you can see, the pods have started spinning up. So I'm currently taking a look at the pods from the Cert Manager namespace. Okay, let's wait till the Cert Manager is provisioned completely. Okay, so as you can see, the Cert Manager has been deployed successfully, and all the pods are up and running. Now, once the Cert Manager is deployed, and once we start provisioning the certificates, Cert Manager needs to validate those certificates first. One of the ways to validate is by using the DNS solver. And Cert Manager has the capability of doing this automatically, provided that we need to give permission to the Cert Manager service account in Kubernetes to create the records in the DNS zone. It can be done with a combination of AKS Workload Identity and Azure Managed Identity. Now let's configure the Workload Identity and Managed Identity. What we need to do is we need to first of all enable the Workload Identity add-on on the AKS cluster that we have. In order to enable the add-on, you can hit this command where we are doing the AZ AKS update, the name of the cluster, the resource group, we are enabling the OIDC issuer, and we are enabling the workload identity. So once you hit this command, the OIDC issuer and workload identity, both of them will be enabled. Since I have already enabled it, as of now, I'll skip this command and we'll move to the next one. Now, next what we need to do is we need to create a managed identity in Azure. So let's go ahead and create it. What I'm doing is over here, I have added this command where I am exporting a environment variable in my terminal with the name of the managed identity. So this will be the managed identity that I'll be creating. The name is E2E SSL Cert Manager MI, and the command that I'll be hitting is AZ identity create, name of the identity and the resource group, right? So if I go back to the managed identities in the Azure, by default I can see that there are two managed identities available, one for the EKS and another for the application gateway, which is perfectly fine. Let's create a managed identity for the Cert Manager as well. So let's hit these commands. As we can see, the command executed successfully and we should have the managed identity created over here very soon. So if I refresh over here, I can see that the E2E SSL Cert Manager MI, which is the name of the managed identity, that has got created. Now what we need to do next is we need to give that managed identity the permission to create the DNS records in the DNS zone that we have created. So basically we need to provide that managed identity a role assignment of DNS zone contributor under the DNS zone that we have created, right? So if I go back in the DNS zones and go to the access control and IAM, this is my DNS zone. I'll go to access control and IAM, I'll go to the role assignments, and as you can see, there is only one role assignment, which is my user, and I have the owner permission over here. Now, as mentioned, I need to give the permission of DNS zone contributor to the managed identity. So let's do it. So what I will do is, in order to give the permission, I'll need the identity client ID of that managed identity. And if I do echo identity client ID, so this is the identity client ID of my managed identity. And now I'll be executing the command to give the role. As you can see over here, I'm giving the DNS zone contributor role to this managed identity, which I am identifying with its client ID. And what is the scope of this role assignment? The scope will be the DNS zone, which is learn with dds.in. So let's hit this query and let's wait for the results. Okay, as you can see, the command is executed successfully. So let's take a look in the role assignments. So if I go ahead over here and press a refresh, I should have the managed identity popping up over here, right? As expected, we have this managed identity, okay, with the role DNS zone contributor. So this is the role that we have assigned to it, right? So now whatever pods that are running with this managed identity should be able to make the expected or required changes in this DNS zone. Okay, let's go to the next part. Now what I need to do is I need to bind that managed identity with the Cert Manager deployments that I have spinned up in the Kubernetes cluster. Now how do we usually bind it? Using the Kubernetes service account. So what I need to do is under that managed identity, I need to create a federated identity where I am mentioning the name of the Cert Manager service account in the AKS, right? So that that service account that I have, all the pods that are running with that service account will eventually get the complete permission to manage that DNS zone. So for this, what I will do is I'll export few more environment variables. Basically the name of the service account. If I go back and I'll go to the access control, and if I see the service account, the name of the service account is Cert Manager, and this is the service account which we'll be using. The service account namespace, of course, Cert Manager is the name of the namespace as well. We will first of all get the service account issuer. Now, once we have the issuer, we will hit the command to create the federated identity. So what I'm doing over here, I'm creating the federated identity credential. The name of my federated identity will be again Cert Manager. This is the identity name, basically the managed identity which I have created earlier. Then the service account issuer, and then the subject that I need to provide, right? And of course the resource group. So once we hit this command, yeah, this command got executed successfully. Let's take a look. So let's go back to the managed identities. Under this managed identity which we have created, if I go to the federated credentials, I can see that the Cert Manager federated credential is created with all the details that I have specified in the command. Now with the creation of the federated identity credential, we are all set to create the certificate. Now in Cert Manager, in order to create a certificate, you need to have an issuer first. So what we have is, if I go to the issuer.yaml, so over here what I have done is I have created a cluster issuer. Now this cluster issuer will help me issue multiple certificates which I need. As you can see, I have this email mentioned, right? So what LetsEncrypt do is it will use this email to contact me about the expiration of my certificate, or if there are any issues related to my account, right? And then as you can see, I have mentioned the server, Acme server, and then I have this DNS solver. Now in the DNS solver, I'm using Azure DNS. The name of the DNS zone, that is the learn with dds.in. If I go back, this is my DNS zone. Okay. The subscription ID that we have over here, and then the client ID. So client ID is basically the ID of the managed identity. Now we have already exposed or exported it in one of the environment variables, right? So if I go ahead and do echo identity client ID, so this is my identity client ID, right? So what I will do now is I'll go ahead and I will create the cluster issuer. Now why I'm using this env substitute command, right? Because as you can see, I'm using an environment variable, value from an environment variable, right? And in order to YAML to pick this value, I'll have to go ahead and use this environment substitute. Otherwise, I'm basically doing just the plain kubectl apply file. If I hardcode that identity client ID in my cluster issuer YAML, I can just go ahead and do the kubectl apply, right? So let me first of all go to the correct directory, and we have this cluster issuer.yaml, this one. Okay, let's use this command to deploy it. Okay, it says the cluster issuer is created. Let's go to our Kubernetes cluster and let's see the cluster issuer. As you can see, we have this cluster issuer ready. So if we check the definition of it, this is the client ID that we have seen earlier, right? That means the cluster issuer is created and its state is ready. So we'll go ahead and use this cluster issuer to spin up this certificate. Now let's go back and go to the certificate.yaml. I'll be using this YAML file to provision my certificate. And again, this is a custom resource of the Cert Manager itself, as you can see over here. I have the Nginx app that I'll be installing and which I'll be exposing. So what I am going to do is I'll be using this DNS name. So I need a certificate which is pretty much equals to this DNS name. So nginx-app.learnwithdds.in. So this will be the subject name of my certificate that I am going to issue. Okay, the issuer ref. So what is the issuer that I'll be using to issue my certificate? This is the same cluster issuer which we have just created. Okay, and I'm giving the renewal window over here, basically 360 hours. Secret name. So this is the secret which will get created once the certificate is provisioned, and in this secret the value of the certificate will get updated. Okay, now what I will do is I'll go ahead and provision this. So over here I have my appset.yaml. So I'll just do kubectl apply -f appset.yaml, and I'm provisioning my certificate over here. Let's go and see the certificate. Okay, now the certificate should be available in the app namespace that I have. I mean the application namespace. So in this namespace, I'll be spinning up my Nginx pod and all other Kubernetes related resources. So the certificate should be available over here itself. So as you can see, the certificate is ready. Okay, now once the certificate is successfully issued, as the message says over here, right, what I can do is I can use this certificate to inject inside my application as well as my app gateway. Let's go ahead and as I have mentioned earlier, this is the secret where my certificate is issued, right? Now if I open this secret, I can see this tls.cert. This is basically my certificate and this is my private key of the certificate, right? If you have gone through my first video, you must have noticed that for end-to-end SSL, we need to put certificate at two places. One is at the front end, which is the part where my browser is communicating to the app gateway, and then at the back end, where the app gateway is forwarding the request to the pod or to the service that I have, right? So what I can do is, in this example, I can use this same certificate as my front end as well as the backend certificate. Since this is a valid CA certificate, I can use it at both the levels, right? So let's go ahead and do that. In order to manage the front end as well as backend certs, what we need to do is we need to upload them in the PFX format on the App Gateway Ingress Controller that we have spinned up. Now the PFX format is a secure format which is used to transfer or store the certificate securely with the help of credentials. So what I'm going to do is I'm going to copy this certificate into this cert.crt. I'm going back and copying my TLS key or my private key in the cert.pem, and I'm going to create a PFX file out of this. Now there are multiple ways to create a PFX file. You can create it with the help of command line, or you can just go to any online converter tool which will convert your .crt and .pem file into a PFX file with a password. Okay, so let's go and do it. So this is one of the websites which will help me convert my certificate into a PFX format. So first of all, what I will do is I'll choose my file. So the LetsEncrypt cert that I have, this is the cert which I am uploading over here, the one which I just copied. Type to convert to, I'll mention PFX. I'll need to upload my PEM file or my key file as well, right? So what I have done, I have uploaded my cert. Let me do it once again. Cert file to the PFX and the key file. So I have uploaded my cert file, I have uploaded my PEM file. Other files like chain or any other files are basically optional. Now what you can do is you can just provide a password. So I'll just provide my password over here and I'll convert the certificate. Now it will basically convert the cert and key into the PFX and it will download the file. So now I have this file in the downloaded format. Now what I will do is I'll switch back to the app gateway that I have. Let's go to the app gateway. As of now, as you can see in the app gateway, we have the default address pool, which is pointing to no target as of now. We have a default backend setting, which pops up whenever we spin up a new app gateway. And then the default listener as well. So we have not done any of the customizations in the app gateway. Now what we will do is we will go into the listener TLS certificate and we will add the certificate. So we'll choose upload. What you can do is you can also store the certificate in Azure Key Vault first, the PFX file, and you can select it from here. But what I'm doing now here is I'm just uploading it since I'll be doing it for one time only. So my name will be learn with dds.in. I'll select the file, so the one which I have downloaded, and the password of the file which I have provided while generating it. Okay, so the certificate is now getting imported, as you can see. Yep, as we can see, the listener certificate is successfully added. Now we are good from the app gateway point. Finally, what we need to do is we need to deploy our workloads. So I have created a few YAMLs. I'll walk you through them. So this is the Nginx config map. So we'll basically go ahead and deploy a plain sample Nginx application, right? What we will do is we will set a custom configuration in the Nginx conf so that the Nginx image or Nginx container that we will be bringing up, instead of by default listening it on the port 80, it will start listening on the port 443. So as you can see, I am editing this default config file, the default.conf, the listen 443, which I am enabling over here. The SSL certificate and SSL certificate key also I need to add, because when the backend request happens, like the app gateway forwards the requests from itself to my Nginx pod or my Nginx service, the certificate must be terminated in order to, or SSL must be terminated in order to serve the request properly, right? So in order to terminate the SSL, I need to have the certificate as well as the private key uploaded securely in the pod or in my Nginx workload basically, right? So which is why I have given this configuration. What I'll be doing is the secret that that the Cert Manager has created for me, which already has the files, the tls.cert and tls.key, these ones. So I'll be mounting this secret at the etc nginx SSL location, right? So this is how my config map looks like. Then let's go to the deployment. This is a very simple Kubernetes deployment. The name is Nginx deployment. Then the image is Nginx latest that we have. Container port, of course, we are going ahead with the port 443. This is the volume mount of the config map. I'm replacing the default.conf file of the Nginx config file, and as I have mentioned, I am going to mount the secret, the app set secret in the etc nginx SSL, right? So that's it. That is the configuration that I need, right? Now, if I go to the service, this will be a cluster IP service for the Nginx pod that I'll be creating. It will be listening to the Nginx pod, as I have mentioned the selector over here, and ports will be the container port will be 443 and exposed port will also be 443, right? And finally, we have the ingress. Okay, before talking about ingress, let's deploy our resources, the config map deployment and the service, right? So I'll go back, Nginx app. Okay, so let me deploy it one by one. kubectl apply -f Nginx config map. Okay, I'll go back, I'll go to the config map. I have this config map created just now and the configuration looks good. Now I'll launch the deployment. Deployment is also created. Let's take a look at the deployment. Yep, it is available. Let's see the pod. Yes, pod is also up and running. If I check the pod logs, yep, everything looks good. That's great. And finally, let's spin up the service. I'll go to the services section. This is the Nginx service that I just spinned up. Let me, before spinning up the ingress, let me just do a port forward on my laptop and let me just try to access it. By that way, I'll make sure that the service is running perfectly, right? So this is saying that the plain HTTP request was sent to the HTTPS port. So it is expecting a HTTPS, but we have done with the HTTP because only the HTTPS port is what we are exposing from the service. So if I do HTTPS, now why it is saying that? Because the certificate is not there yet, right? We haven't attached the certificate and we haven't created the ingress. Okay, if I ignore that warning, I'll see the landing page of the Nginx. That's great. Let's go back. I'll stop the port forwarding and let's jump into the ingress. Okay, this is the interesting part. Now, as you can see, what I'm doing is I'm creating a ingress resource with the ingress class name as Azure Application Gateway. So as soon as this ingress is created, Azure Application Gateway should create a backend setting and a listener for me, right? So that my traffic works as expected. So let's focus at the annotation. Now what I need to do is I need to enable the backend certificate as well, right? Backend SSL as well. I have already enabled the front-end SSL, but I need to enable the backend SSL as well. So what I need to do is this, you remember the certificate which we have uploaded earlier in the app gateway, right? In the form of PFX file. I'm giving the name over here. So if I go back to the, yep, we are already over here, app gateway, yes. So this is the certificate which we have uploaded, right? And with this name, learn with dds.in. So the same name I'm giving over here. Now the backend protocol, by default, the backend protocol is HTTP for any of the ingress controller or load balancer for that matter. But over here, since we need to implement end-to-end SSL, we are going to keep the backend protocol as HTTPS. Health probe port, health probe path, whatever the Nginx needs, SSL redirect to true, that's it. Those are all the annotations I'll need. And then I have, of course, the ingress class name. Then under the rules, I need only one rule because as of now I'll be doing the host based routing. Now over here, the host which I have mentioned is the URL that I want to hit, right? nginx-app.learnwithdds.in, okay, and which will redirect the traffic to my Nginx service, the cluster IP service that I have created, which is exposed on the port 443. So as simple as that, right? Let's go back and create the ingress. Nginx ingress. Okay, let's take a look now. We go to the ingress. Our ingress is pinned up. It has a IP. So if you notice, since I'm using the app gateway ingress controller, whatever is the front-end IP of the, or the front-end public IP of the app gateway ingress controller, that will be the IP of my ingress resource. Basically, if I go back to the app gateway, go to the front-end configuration, as you can see, this is the same IP address, right? Now let's take a look at the backend pool. Now in the backend pool, earlier we saw that the target was not registered. As we can see, now the target is registered. In the backend setting, instead of the default, I have the Nginx service backend setting now, which is pointing to the port 443. In the listeners, I have a new listener, this second one, which is pointing to the port 443 again. And if I open that listener, I have the certificate learn with dds.in. So this all is done because of the annotations that we have used, right? The backend protocol, SSL redirect, and the SSL certificate. So this is how the app gateway knows what listener to create and which certificate to attach in the listener. Okay, going back, let's do a health check quickly. So if I go to the backend settings, let's see the backend health. If my backend is healthy to serve the traffic, great. As you can see, my backend is healthy. It should be able to serve the traffic now. Now, the last part is I need to create a record. So if I go back to my ingress resource and look at the host that I need to access this is with nginx-app.learnwithdds.in. Now I'll go to the learnwithdds.in. This is the zone that I have already have. I'll create an A record, nginx-app. I'll set the TTL, and for the IP address, let's get the IP address of the ingress controller load balancer IP, basically the app gateway ingress controller IP address. I'll put this IP, adding the record set, Now let's go back and see if the IP is getting resolved. Yeah, I'm doing over here NS lookup nginx-app learn with dds.in, and this is resolving my IP perfectly. Now the final check that we need to do is we need to access the website. https nginx-app learn with dds.in. Yep, as expected, it works perfectly. Now if I go over here and click this lock icon and go to the certificate details, this is the certificate which we have spinned up, the nginx-app.learn-with-dds.in. So this is the certificate which we have spinned up with the help of Cert Manager and LetsEncrypt. Okay, so let's summarize what all activities we have done. First of all, we have spinned up the infrastructure with the AKS Kubernetes cluster, the app gateway ingress controller, and then we have created a DNS zone, registered it. These were the prerequisites. We have configured and installed Cert Manager. Once the Cert Manager is installed, we have configured Workload Identity as well as Azure Managed Identity, so that the Cert Manager has permission to create the necessary record, ACME record, in the DNS zone to validate the certificate as part of the DNS solver. Then we have provisioned the certificate issuer, and we have provisioned the actual certificate with the help of LetsEncrypt. Once the certificate is provisioned, we have converted it into the PFX file and uploaded it on the app gateway. Lastly, we have deployed our workload, that is the Nginx pod, the service, the config map, and finally the ingress controller with a specific set of annotation which will help us enable the front end as well as backend SSL. That's it for today's video. If you found this video helpful, please do not forget to like, share, and subscribe to DevOps and Data Simplified. Let me know in the comments if you have any questions regarding the same. I'll be very happy to answer. Or even if you have any suggestions to what topic I shall cover in my future videos, please let me know. I'll be very happy to go ahead and do that. This is Kalpesh signing off. Thank you so much.